Hi students, hope all of you are doing well. In this testing time, I hope all of you are safe at home. Today we will be starting a new part of our module. Okay. That is method of solving linear algebraic equations. Okay. So basically to solve this linear algebraic equations, we generally follow two methods. Okay, one is direct method, another one is indirect method. So you can write it down. In direct method, the main thing is you can write it down. The solution is obtained after a finite number of steps. The solution is obtained after a finite number of steps of elementary arithmetical operations. Fine. That means after some of arithmetical operations, we'll be reaching the goal. Okay, and for that, only finite number of steps are required. Fine. And now for indirect method, you can say it is an iterative method. Okay, so in iterative method, what is the background is, we will start with an initial approximation of x. Okay, initial approximation, then slowly we will be converging. Slowly it will be converging towards the goal. Okay, it may take, ideally it should be infinite steps, but after some steps we will be converging towards our result. Means though it can be infinite, it is the infinite number of steps ideally, but after each step it will converge. Okay, it will converge slowly. So for indirect method, you can write it down. We start with an arbitrary initial approximation to x. We start with an arbitrary initial approximation to x and then improve this estimate in an infinite but convergent sequence of steps. Fine. So basically, these are two general methods. Today we will be learning a direct method known as ALU decomposition method, or sometimes they will call factorization method. Okay. Now to know about this method, first of all we need to know who is the captain of this method. There is a captain of every team, right? So who is the captain here? The matrix. Okay. So matrix is the captain of this method. That means all operations will be done, all matrix operations will be done. Okay, then matrix or matrices will be playing a vital role in this method. So from higher school mathematics, you will know all the operations of matrix, right? So mainly we need the multiplication property of matrices. Fine. So before starting the method, one thing you need to know: what is upper triangular matrix, what is lower triangular matrix. You can write it down. In upper triangular matrix, I have written in short UTM. All elements below principal diagonal elements is 0. All elements below principal diagonal elements are 0. That means, for this case, all elements below principal diagonal elements. Now what are the diagonal elements here? This and this. So all elements below this diagonal element should be 0. So for this case, this 2 will be 0. For this case, this will be 0. And if I take 3 cross 3 matrix, square matrix, then it will be like this. Okay, why have we kept 1? I will come to that later. Okay, so this is basically your upper triangular matrix. Now what is lower triangular matrix? Same thing, just instead of below, you write it above. Okay, so check it here. So all elements, principal diagonal elements, all elements should be 0 above principal diagonal elements. These are your diagonal elements, right? Above these diagonal elements, the other elements will be 0. So this is your lower triangular matrix. In short, I have written LTM. Fine. So these two things we need to know. Now, suppose this is a system of linear equations. What is this? A11 x1, a12 x2, like that way. If I take n number of terms, then ain xn, and this is your A or B1. In likewise, the second row will be A21, second row but first element. Okay, x1, then second row, second element. So A2 to x2, like that way, we will reach A2n xn, and it should be equal to B2. Like that way, if I have n number of terms, then last term should be n for nth row, it's an1 x1 plus an2 x2, like that way, ann xn is equal to, it should be equal to bn. Okay, so this is your linear systems of linear equations. We need to solve this. Okay, so to solve this, first of all, we need to know two things. Pick the coefficients from here. Pick the coefficients. That means A11, A12, like that way, A13, A14, pick it. And this also. So if I pick these elements and I have set it to a matrix, we will get a new matrix, right? It will be a square matrix, and it should be, that is what I have written here, A. So A is basically, you can write A is coefficient matrix. Okay, that means it will contain all the coefficients except this B. Okay, so now remember one thing, to get a proper solution, this A matrix should be non-singular. That means the determinant should not be 0. It should be non-zero. Okay, so make sure that coefficient matrix should be non-singular. Fine. Now what is B? B is basically these terms. If I pick this B values and I set to one matrix, we will be getting a new matrix, right? And that is what I have written as B, and it is called right hand side vector. Right hand side, see in the equation part, it is in the right hand side, right? So right hand side and vector. Fine. And this x1, x2 and x3, just simple, there are three. If I choose n number of x, right? So x1, x2, like that way up to xn, we will be putting to another matrix, that is x. This is the solution vector. Means our goal is to find this matrix, or you can say find the value of x, x1, x2, like that way. So from your high school mathematics, you can say if A is a matrix, non-singular matrix, what you can write? You can write it as a product of this upper triangular matrix and lower triangular matrix. So this one I have written as U, and this one I have written L. So A is equal to LU. Fine. And from this equation, the A into this x is equal to B. Okay, so A means all the coefficients of this, and x means x1, x2, xn, and B means all the B values. So if you multiply this, you will get this. If you multiply, you solve this, then you will get this, the whole system you will get. Fine. So now we know Ax is equal to B, but we know A is equal to LU, right? Product of lower and upper triangular matrix. So if I put this LU here, then what do you get? LUX, right? LUX is equal to B. Then what I am writing, this UX I am writing as Y. So LY is equal to B, and finally UX is equal to, and we have chosen UX is equal to Y, right? So UX is equal to Y. So these things you need to know. So to solve this method, this system of equation through this method, first is to find the elements of this L and U. That means to find the values of all these coefficients and these coefficients. You need to find this value, these elements and this element. Fine. So first of all, see what is LU. LU. What is LU? If I LU, that means we need just simply multiply this to matrix. So if you simply multiply this matrix, you will get this one. Right? See, matrix multiplication I hope you know, in this way and in this way. So L11 into 1, then 0, all zeros. So L11. Fine. For this case, L11 into U12 and all will be 0. Like that way. L11, U13 and all will be 0 for this case. And for this one, L21 will exist and others will not exist. And for this one, L21, U12, L21, U12 and L22 into 1 plus 0 into 0 plus 0. Fine, so you'll get this term. In this way, I hope you know the matrix multiplication. So simply take out a pen and paper and find the product of these two matrices. You will get this. Fine. Now see how I can use this. So what our first objective? To find these coefficients. Okay. So before explaining this in this way, in this general way, let me take an example. Okay. Through an example, it will be easy for you to understand. Okay. So see, here is a question. 2x1 minus 3x2 plus 4x is equal to 8. x1 plus x2 plus 4x3 is equal to 15. 3x1 plus 4x2 minus x3 is equal to 8. We need to solve this. Okay. And what you need to find the values of x1, x2 and x3. Okay. This is our object, to find the value of x1, x2 and x3. Fine. So what you will do first? Pick the coefficients, this, and it will be set to A. I told you it will be set to A. So 2, minus 3, 4, 1, 1, 4, 3, 4, minus 1. So this is your coefficient matrix. Fine. So we have written the coefficient matrix. We have identified the coefficients. And what is your B? I told you these are B values, right? The right hand side vector. So 8, 15, 8. 8, 15, 8. Fine. Now what I told you, we need to find, we know A is equal to LU, right? So A is this one and it should be equal to LU. LU means this, the whole thing, right? So what you can do is, you can compare this one with this one. Compare this one with this one because these two are equal, right? These two are equal. This one and this one. So if I compare, what is my L11? It is basically 2. So L11 is equal to 2. So after comparing, we'll get 2. Fine. Then what is this L11 U12? It is minus 3. So L11 U12 is minus 3. Now see, L11 we know from the previous step, that is L11 is equal to 2 because already we have got this value. So what I can do, I can find the value of U12. U12 is minus 3 by L11, that means minus 3 by 2. Fine. So in this way you can find the value of U12. Next, what is the next term? Next term is 4. 4 means L11 U13. So L11 U13 is equal to 4. Next, since L11 we have already calculated, so now we can calculate U13 is equal to 4 by 2, that is equal to 2. Fine. Now in this way we have solved all the values of L and U elements. Okay. So just you need to compare with this. Suppose for this case, what will happen? This one is basically is equal to -1, right? So if you compare it, you will get this one. Okay, so just compare and find each solution and just solve, and you will get the values of this L11, L21, L22, L31, L32, U12, U13, U23. Fine. That means the three terms, 3 and 3, 6, 7, 8, 9. 9 elements you need to find out. So here just check it: 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 elements you need to find out simply by comparing with A, with the coefficient value A, with the coefficient matrix A and this ALU. Fine. So this is our first step. Next step is what I have written here: Ly is equal to B. Okay, so we know what is L, right? L is this one, and already we have calculated what are the values of this for this problem. Okay, so we know L, but we don't know Y. We already know B. Fine. So what you need to do? The unknowns are the Y values. So find the elements of. So next is find elements of Y. Okay, next step is, so Ly is equal to B. We know L is this values, the values of L, then into the Y is equal to B. This is my B matrix, this is my Y matrix, this is your L matrix. Fine. So in this way, if I just find the product of these two matrices, okay, and if I just compare, then I will get this. For this one, 2y1 is equal to this one. Okay, so from here y1 is equal to 4. Similarly, I can write y1 plus 5 by 2, y1 plus 5 by 2 is equal to 15. From there I can calculate y2. And for this one, 3y1 plus 17 by 2 y2 minus 69 by 5 y3 is equal to 8. That means which will give us y3 is equal to 3, because we already know the value of y1 and y2 from these two steps. Fine. So basically what we have done is we have calculated the values of y matrix, elements of y matrix, y1, y2, y3. So this is basically a 3 dimension. The dimension is 3 cross 3, right? So only 3 elements you need to find out. So second step is over. Fine. So what is the third step? Third step is ux is equal to y, right? Because we have put here ux as y. That's why we get Ly equal to B. So last step is to find the elements of x. This is our aim, right? To find the value elements of x. You will get it from this step only. Okay. So see, what is u? U is this one. We have already calculated what is the value of this from this. So I have my U matrix is this, x I don't know, since there are 3 unknowns, so x1, x2, x3, and y we have already calculated from step 2, right? So put it here. So it is 4 to 22 by 5, 3, 4, 22 by 5, 3. Fine. So again the process is same. Simply multiply this, okay, and equate with this. So see, first x1 minus 3 by 2 x2 plus 2 x3. This should be equal to 4. Okay. So for the second case, x2 0 into x1 is 0 plus 1 into x2 is x2 plus 4 by 5 into x3. So 4 by 5 x3. Okay, this is equal to 22 by 5. 22 by 5. Finish. And for the last case, only this term is left. So x3 is equal to 3. So x3 is equal to 3. So here, see, in the last step, we have got the value of x3, which is 3. Okay. So remember one thing, we will get x3 first. Then what we can do? The process of back substitution. So if I know x3, I can put this value here. Then I can calculate x2. Similarly, if I know x3 and x2, I can calculate x1 because x3 we know. X3 we know from the first step, from this step. X2 we have calculated from this step. Then we can calculate x1. So if I do this, I will get x1 is equal to 1, x2 is equal to 2, and x3 is equal to 3. So first we have calculated this one, then this one, then this one. So this is your result. 1, 2, 3. Okay. So now see, you can check whether your result is correct or not. See, x1 is 1, right? So x1 is 1. x2 is 2, x is 3. So if just multiply, 2 into 1 is how much? 2. Minus 3 into 2 is 6. So 2 minus 6 is minus 4. Plus 4 into 3, 12. So plus 12 minus 4. How much it is? Plus 8, right? So plus 8. That means our solution is perfectly okay. So this is your method. So basically what we have done is, first step is to find the elements of L and U matrix. Second step is to find the elements of Y. Third step is to find the elements of X. And to find the elements of L and U, you need to apply A is equal to LU. A is equal to LU, this formula. And then you need to compare and you need to find out the values of U matrix and the L matrix. Second step, have to apply this formula, lie B. Lie B, right? Lie is equal to B, lie B. And this one is ask Y. Ux is equal to Y. This will help us, this equation will help us to find the elements of X. So this is your process of LU decomposition method. So you can choose any problem and solve, proceed in this way, you will reach the result. Fine. So before concluding, one thing you can note it down is, first of all, the diagonal elements of L, it can't be 0. It can't be 0. If it is 0, then the whole original system becomes singular. That means we cannot apply this LU decomposition method. Okay, so to apply this method, L11, L22 and L33, that means the diagonal elements of L should be non-zero. Fine, you can note it down. This is one thing. Another thing, sometimes they will say Kraut's method. What is Kraut's method? See what I have written here, unit UTM. What is UTM? Upper triangular matrix and unit. Unit means, remember, the diagonal element should be 1, unity, 1. So see, in this case, this is your UTM, upper triangular matrix, but the diagonal elements are 1. I told you I will explain this later. So for this case, see, unit UTM, right? The unit means the diagonal elements are 1 and it is an upper triangular matrix. This is fine. And another thing, in Kraut's method, that means LTM. What is LTM? LTM is basically lower triangular matrix. So basically, if in the exam they say Kraut's method, that means this same thing. What I have done, this is basically Kraut's method. Fine. Sometimes they will ask like this, Doolittle's method. Doolittle's method is basically the opposite case. Here the UTM should be normal, and this LTM should be unit. So that means for this LTM, the diagonal elements should be 1. That means for this case, this diagonal element should be 1, 1, 1, and other things will remain the same. Fine. So that's why I am taking a unit LTM. Unit means the diagonal elements are 1. You need not to worry about. And what is the UTM? UTM already you know. It is simply upper triangular matrix. The formula will remain the same. A is equal to LU, Ly is equal to B, and Ux is equal to Y. Fine. Everything will remain the same. Fine. So before concluding, one thing you can note it down, or you can skip also, no problem. See how we have calculated this U values or L values. Generally, since it is 3 by 3 cross 3 matrix, it is easy to solve. In the exam, I hope they will ask 3 cross 3. If I want to find the value of L and U, my general expression is this. See, Lij, it can be 1, 2, right, is equal to Aij. A means the coefficient matrix. See, you can map with this. You can map this to, and you will see these are coming. Minus summation of k is equal to 1 to j minus 1 Lik U k j. And this is the note here, I should be greater than equal to j. You need not to worry, say A minus suppose LU. So just choose any one L and see, this is your A part, the coefficient matrix, and this is your L into U. See, L into U. So for n number of for general case, we can find out like this way. And U also, if you can map with this one, see, it is Aij, and this whole thing will remain the same. Okay, Lik, Ukj, the same will be same, and it should be total divided by L1, 1. L1. And remember one thing, the condition here is I less than Z. Okay, I less than Z. So the same thing, it should be divided by the L. Divided by L. Fine. So this you can remember, or you can skip, because you know how to solve simple equations, right? So in general, you can apply this. Okay. So before concluding, one thing I will try to give you a trick. So remember one thing. First step is A is equal to LU. Second step is Ly is equal to B. Third equation is X is equal to Y. These three equations will help you to get the solution. Okay. So remember this trick, this small trick. What I have written here? Eating ALU, lying the boss, finally asking why. Eating ALU means, you can say ALU. ALU means in Hindi or in Bengali, this is a potato, right? So eating this ALU, lying the boss, finally asking why. So see, eating ALU, see the second sentence. ALU means first is ALU, we need to apply A is equal to LU. Then lying means Ly, lying the boss. B is the B matrix, the boss. Final step is UX, asking why, right? Why? So you can map with this, you can remember this trick. Okay, so A is equal to LU, Ly equal to B, UX is equal to Y. Fine. Or you can remember in other way also, ALU, lying in the bed asking why. That means ALU, lying in the bed asking why. See, ALU, Ly, B for bed, and asking UX, Y. That other things remain the same. Or you can remember this one also. ALU, lying in front of boss. ALU, Ly, in front of boss. In front C, in front B. The Ly is in front of B, right? In front of B, asking why. UX, ing, Y. Okay. So this is a small trick for you. So in this way you can remember this. So this is a method, this is a direct method of solving linear systems of equations, linear algebraic equations. Fine. So I hope you have understood. The method is very easy, simple matrix operations needed, 3 equations you needed. Okay, you need to remember 3 equations and then you will get it is the result. One thing you need to know, the elements of L, the diagonal elements of L can't be 0. Okay, and the A matrix, that means the coefficient matrix, should be non-singular. Okay, so that's it for today. Take care, stay safe. Thank you.